Firstly, I'd like to acknowledge that we're meeting on the lands of the Wurundjeri people of the Kulin Nation, and to pay my respects to their leaders, past, present, and emerging. Today we have Helen Fraser to speak to us. So Helen's in the, I guess it's the linguistics department, linguistics and language science, is that what it's called?
Languages and linguistics.
Ah, okay, rightio. Very good.
Completely different.
Here we go. Well, having been part of some of the meetings that go on about these names, I know there's probably like an hour of discussion about which order it should go. So today, Helen's going to be talking to us about deciphering indistinct foreign speech recordings, practical challenges.
Forensic.
Sorry.
Well, some of them are foreign.
Right.
Both foreign and forensic. Okay, I'll get started. Thanks, everybody. I'm very happy to be here. I was going to be coming a few months ago and wasn't able to for various reasons that I can't remember. But the sad thing was I would have been just after Frank Molliker, who you may remember gave a speech. Oh, that's you. I was about to say what a terrible performance it was. No, it was a brilliant performance, and it was also all about language and the law, and I'm about language and the law as well. So I'm sorry I didn't recognize you. But it was very, very interesting. I recommended it to lots of people after hearing it. So that's now a few months ago instead of just last week, but maybe you can cast your minds back. This is kind of related. So yes, I'm Helen Fraser. I'm in another hub. I like to call it the real hub. You're the other hub, Research Hub for Language in Forensic Evidence. And we also deal with complex human data. So I thought it might be nice to just have some discussion. May or may not be of interest to you, but you're stuck here for an hour. So I'll tell you what I've been doing. Maybe. Okay, so I'm going to be talking about indistinct forensic speech recording. So it's probably a good idea to start by giving you an example. So forensic speech recordings are recordings used as evidence in criminal trials. And they're typically from covert recordings, so recorded secretly. They're often of very poor quality. So here's an example, 14 seconds from a much longer recording. So just listen if you've got a pencil to hand, jot down what you hear. If not, remember what you hear, and we'll discuss it afterwards. Anybody write anything down?
Yeah, I don't think it mattered that I didn't have the pencil.
Typically, nobody hears the confession to murder. So you can laugh, and I laugh. It is funny. I'm not blaming you for laughing, but it's pretty serious. So listen again now with the transcript. Transcript will be on.
Label.
Does it help? Well, we've done a lot of experiments on that. It does help some people. About a quarter of the people tend to hear that. In the trial, it was extremely powerful evidence. The pact that he's referring to is a pact to commit murder, made the murder a joint criminal enterprise, and there was a guilty verdict, and he was sentenced to 30 years in prison. So that shows you the value of forensic transcription. Yeah. Seem to have lost this thing again. And of course, it relies on the transcript being right. So our mission is to make sure we get correct transcripts. That one is incorrect, inaccurate transcript. And in fact, that's very common. So you might say, well, who makes these inaccurate transcripts? And the answer is they're made by detectives from the case. So when I first discovered that, I was very surprised that the law allows police to give their opinion as to what is said in this kind of audio. And I said, why on earth would you allow detectives to do that? And the answer was, well, why wouldn't we? They're the ones who can hear what's going on. So I think you can see this is clearly wrong. There's a reason that police can hear what's going on, because they already know what's going on, and this primes their perception. It's very obviously wrong to anybody who knows about cognitive science, perception, linguistics, all sorts of things like that. Nevertheless, it's been established by legal precedent that goes back to 1987, then 1982, 1966, even further. That's not completely crazy. There are safeguards. They don't just hand over the detective's transcript to the jury. They do have this system of safeguards. The defense has to check it. If necessary, the judge will check it. And then the jury is instructed to use it only as assistance. But these safeguards are ineffective because the transcript primes everybody, including the judge. Nevertheless, these procedures are embedded in standard legal and law enforcement practices across all levels. And it's a cause of substantial injustice. So this guy died in prison, having been sentenced to 30 years. I'm personally convinced he was not guilty. That was the crucial evidence in his case. And there are many examples of inaccurate transcripts being given to assist juries. Of course, it's only discovered mostly retrospectively, and very few are discovered, but it's likely that there are many more that remain undiscovered, and many more will still come because these laws are still in place. So if you're feeling a little disturbed by this, good, I've done my job. We should be disturbed by this. This has all been done in the law with no consultation of linguistic science or cognitive science. So you might be thinking, oh, well, that's okay. There's an obvious solution. Have an expert evaluate the transcript. But it's not that simple. We have multiple examples where experts have disagreed with the police version. Sometimes even experts on both sides disagree. Multiple experts on both sides disagree and or agree that the police version is wrong. But the judge still allows the police transcript to assist the jury. So the problem isn't the fact that the police do the transcripts. That is not ideal, certainly, but it's not the main problem. The real problem is the law believes that they can evaluate the transcripts. They don't recognize the power of priming to propagate these errors throughout the whole court and to the jury. And the reason is that the law considers that understanding spoken language is a matter of common knowledge. They do recognize the power of bias and suggestibility, and they aim to protect the jury from being influenced by an inaccurate transcript, but they believe that careful, responsible listeners can hear what's there to be heard, and thus the lawyers, the judge, and the jury are able to evaluate transcripts, whether they're by police experts or anybody else. So they may have a police transcript, and then they may have one or more expert transcripts or expert opinions, or they may not, just depends if they're called or not. But either way, lawyers, judges, and juries have the end say in all of it. So science knows that this is wrong. I think you can see that. Usually I explain all this, but I think with this audience, you can clearly see that that's a big problem. And we can offer a better way. And one way I've thought would be useful would be to create a test. It's clearly not enough just to ask the jury to listen carefully. We need some sort of test to confirm that they're hearing accurately. So the test that I suggested was that instead of just listening and say, yes, I hear it, they should be asked to locate exactly where they hear the words in the flow of the recording. So I've done some experiments to test the effectiveness of this, and you can have a go at one of the ones I've done. Your task is to locate the words Adelaide bank account. So put up your hand or think about it to see when you hear it. So that's pretty successful. The experiment said 100% located it correctly just before the middle where you all saw. 68% were definite. So great, that's a much better way to evaluate a transcript. Just one slight problem, that transcript is wrong. It's not a police transcript, I just made it up. with the deliberate intention of tricking lawyers and judges, just to show them how unreliable their own perception is, even when they're being careful and listening responsibly and they're unbiased and neutral like you all are. To make the point that even careful, unbiased listeners can be primed by an inaccurate transcript. So these safeguards that rely on careful, unbiased listeners are ineffective. And this was very successful as a demonstration, because many judges and legal scholars have now agreed that the current system is flawed. But the problem is they can't change it. It's all embedded in legal precedent, like I said before. So it really won't change until we have a demonstrably better way, because if nobody can hear something and the police put forward something that helps everybody to hear, and there's legal precedent that says that that can be put before the jury with the relevant instructions, that's what's going to happen. So science can help, not in that way like that test. That was a sort of a trick for a demonstration. But I think the way that science can help is to get the law to recognize forensic transcription as scientific evidence. It's not just a matter of common knowledge. It should be treated like other responsible forensic sciences, and the law should respect the opinion of experts, not accept it blindly, but respect it, not invite the jury to disagree and reach their own conclusion. And this is extremely hard for matters that are considered to be common knowledge. I'm sure you've been exposed to changes that are happening in the law with respect to eyewitness evidence. At first, the law just was eyewitnesses. Sure, they're the best kind of witness, but now we know they're highly inaccurate. It's always been assumed that we need the jury to see the witnesses because the witness's demeanor helps to know if it's true or false what they're saying. But we now know that demeanor is not correlated very well with reliability. Same with rape reports. It used to be common knowledge that a genuine rape victim would immediately go to the police and report the rape. We now know this is certainly not true in all cases. So this kind of common knowledge, those of you who like psychological biases probably know about the illusion of explanatory depth. Things that we do all the time seem so familiar that we think we understand them, but actually we don't really understand very well at all. So this situation needs linguistic science to step up and be able to provide demonstrably reliable transcripts from the start of the trial, not just provide an opinion to assist. So that might seem straightforward. Just get an expert in to analyze the acoustic structure of the sound. Actually, that is surprisingly hard to do in practice. Acoustic analysis is a very powerful tool. I am a phonetician. I love acoustic analysis. It's a very powerful tool, but it's not capable of determining the content of poor quality audio like you've just heard, with unknown content and potentially misleading context. Certainly not to the level of consistent reliability that is required for the forensic sciences. So that's not a criticism. I say again, I am a phonetician. Acoustic analysis was never designed for that purpose. It was developed and intended for use on audio with known content, and has made many important, useful, and surprising findings about the nature of speech. So I'd like to share some of those findings with you. So here is a quick demo to give you an impression of the nature of speech. And we'll start by asking you to read the sentence that's written backwards. Can you read it? In case anybody can't read it. That's what it is. So the point is, written text backwards is very easy to read. Now I'm going to invite you to listen to a sentence that is spoken backwards. Are you ready? Anybody understand it? It's not quite so easy.
The cat sat on the mat. The cat sat on the mat.
So what does this tell us? Spoken language is nothing like written text, okay? So if we compare common knowledge and the nature of speech, according to common knowledge, we all learn when we're like 4 or 5 years old we learn to write. We take speech and present it as written text. And we actually learn the cat sat on the mat, and we learn that a k and an a and a t makes cat, and all of those sorts of things. And this gives us the impression that speech is similar to printed text. Of course, without the inconsistencies of spelling. It's representing phonemes rather than letters, but let's put that aside. So early scientific discoveries showed that that's not true. Speech is continuous. The sounds blend into each other, and this was at first ascribed to co-articulation. If you've studied any linguistics or phonology or phonetics, you definitely have heard of co-articulation. Each sound influences the other sounds around it. So it was thought that this was kind of like a handwriting font. So the letters are joined up and the words are joined up. There's no spaces. And they discovered when they, in the 1950s, they tried to make a reading machine for the blind on the basis of this idea by, when they had the capability of synthesizing sounds. You synthesize a th and a and a k and an a and a t, and you put them together, and guess what? Nobody can understand it. It's nothing like speech. And gradually over the years, through many ongoing discoveries, not only is speech continuous, but it is highly variable. It's nothing like that kind of Lucida handwriting font. It's actually like real handwriting, except very messy and still with no gaps. So let's look at some messy handwriting backwards. Can anybody interpret it? God, Hannah, you didn't even try. Good.
The quick brown fox.
Well done. See, I'm glad I asked you to try harder. You got it. Okay, but you see my point? It's nothing like what I showed you before with the cat sat on the mat, where everybody without even thinking about it can interpret it. And I want to emphasize that this kind of handwriting is much easier than real speech. That's just 2 dimensions. It's one line snaking across the page. Speech has multi-dimensions, all sorts of things. It's very, very interesting. I'd love to spend much more time telling you about it, but I'm not going to go into it. The point is, even with handwriting, if you accept that speech is far more complex than that, you can't get from messy handwriting to printed text without knowledge of the language. Imagine if that was another language or another script, you'd definitely not be able to even begin to interpret it. When you were guessing the quick brown fox, you were using your knowledge of English and your knowledge of English handwriting and all sorts of things. And you usually need some context. If just one of those letters would not be easy to understand on its own, you need it within the context. Okay, so what's the effect of all this variation? I'm going to give you another quick demo. I'm going to play you 3 English words. So this is very short. And if you can, tell me what they are. If you can't, tell me, are they the same, different, whatever you can say. Okay?
J, N, J. J, N, J.
Second one's different. All 3 are different.
All 3 are different? Gotcha. Now listen in context.
First year, second year, third year. First year, second year, third year.
Watch.
J, J. N, N, J, J. First year, second year, third year.
So do you believe me? Let's go back.
J, N, J.
Much easier now? A little bit. I want to emphasize that is very clear speech. It's an extremely clear speaker, me. And it's the same, and it's a very clear text. It's separated out. It's the same speaker. It's the same good recording conditions. Nevertheless, it's impossible to determine the phonemes without knowing the context, without hearing the context. And I'm lucky enough to know some of the top phoneticians in the world. And I've given lots of them that demo, including giving them a spectrogram with the acoustic information. Nobody can do this. This is an impossible task. Now, that does not detract for one moment from the expertise of phoneticians. We have done, we as my discipline, have done an incredible amount of research. Anybody who knows anything about linguistics could talk to you for 20 minutes easily about that phenomenon. There's an enormous amount of information known about this kind of thing, but only after they know the content. So do you see what I mean about acoustic analysis is great when you know the content, but it does not enable you to determine the content. And in fact, it's worse than that. It's not just that it doesn't enable you to determine the words. Determining the phonemes requires you to know the words. So it's like this weird bootstrapping problem. Okay. Better race along a bit faster probably. So the implication is we can't do speech perception bottom up, especially not in extremely poor quality forensic audio where we don't know the content and the context is potentially misleading. So this common knowledge idea that the law is based on, that speech perception is just a matter of recognizing phonemes and putting them together into words, can't possibly be true. There are no phonemes to recognize. And without going into detail, let me assure you, there are no other units of any kind in any kind of one-to-one correspondence with any linguistic unit, such as phonemes, words, syllables, morphemes, etc., etc. It's very well established that words cannot be recognized by purely bottom-up processing. So that acoustic analysis, everything we know about acoustic analysis kind of predicts that this is not the solution for forensic transcription. Nevertheless, a lot of phoneticians feel very disappointed that they can't do this, and many front up to court and say, yes, I'll do this kind of analysis. So I think that's slightly problematic, but it's not really very possible. It is possible to give an opinion about an existing transcript, but it's usually easier to so in the real case examples where the multiple experts all agreed it was wrong, true, they all agreed it was wrong. It is much easier to rule out an incorrect transcript, at least to the satisfaction of scientists, if not to the satisfaction of the court, than it is to say what it is. So very frequently, experts will agree that the police transcript is wrong, but will give different opinions as to what it is. There will not be agreement about what the correct interpretation is. And this diminishes trust in science. To my mind, that should say, my goodness, if even the experts can't agree, that shows that this is very difficult. But to the courts, oh, those eggheads, what would they know? We'll have to take it on ourselves. We'll leave it to the jury under instruction from the judge. So in case you're wondering, enhancing is not the answer. I've put a little reference by me in the conversation there. I think that's a cute little article if you're interested. It gives you some demos like the ones I've just given you here. And in fact, even with recent developments, AI is not the answer either. If I've got time, I'll say a bit more about that in a while. So we need a new approach, not acoustic analysis. We can't just give up. This is a problem that needs a solution. I'm saying that because a lot of academics do just give up and say, oh God, what can we do? Oh my gosh, I just realized I've still got my volume down, haven't I? Okay, that's better. So what I'd like to do is define what I call a forensic question, which is, well, okay, how can we decipher indistinct speech of unknown content in potentially misleading contexts? Now, we actually have a fantastic tool for that, because that's something we all do every day. That's what human speech perception is. We generally don't know what the content's going to be. We very often listen in misleading contexts or unknown contexts, and we're very, very good at it. So the approach, when I say hub, I mean my hub, not your hub. Our approach is let's exploit those human listening skills and human abilities to develop a better way of doing forensic transcription. So this usually raises a lot of red flags. The immediate concern is this is very subjective. Yes, human listeners are very skilled, but they're also very error prone. They can be confident but wrong. And I've just shown you a few forensic examples. I assure you I just gave you one, really. There's loads and loads of examples. I'll give you a website at the end if you're interested. But the fact is, listeners are involved in forensic transcription, whether we want them to be or not. The transcript purports to represent what the speaker said, but it really represents what the transcriber heard. The thing is that speech perception is so automatic and so apparently transparent that the distinction between what the speaker said and what the transcriber or the listener heard tends to be blurred and overlooked. So that's where we get this problem that I've just been showing you, where listener error gets propagated and becomes a transcript error. And as we'll see, transcripts, it's not just one listener writing the transcript and that's the end of it. Listening is involved in, transcription is a very complex thing. It's much more than just creating a transcript. We also have the end user who's going to be using this transcript. They're a listener too, especially in this forensic context. The whole point of forensic transcription is not to give some fancy transcription in IPA or some intonation thing or conversation analysis thing or something like that. It's to represent what one listener hears in order to assist others who can't hear. And this is a very unusual form of transcription in linguistics. And that limits the transferability of linguists' experience with transcription. But the point is, the most important thing is, if the listener is wrong, the transcript will be wrong. If the transcript is wrong, the next listeners who use it as assistants will be wrong, and on it goes. And most importantly, the evaluator is also a listener. We've seen that in relation to lawyers, judges, and juries, but it's also true for experts doing apparently objective acoustic analysis. So we think acoustic analysis is very objective. We're looking and observing the actual sound, not just being biased by our perceptual processes. But you can't do acoustic analysis without listening. And many acoustic analysis experts are not experts in listening. I'll show you a little bit more about that later. So the attempt to be objective in that sort of sense really kind of drives the subjectivity, inevitable subjectivity underground. Currently, in the current legal procedures that I've just outlined for you, all those listening roles and more are filled by non-experts. They're untested, they're unmanaged, their situation is uncontrolled, the whole thing is unaccountable. This is completely at odds with the requirements or the demands of forensic science, as we see through the President Council and other innovations that have been brought in over the last 10 to 20 years and are adhered to in general very strictly for other forensic sciences. So our aim is that all those listening roles should be filled by accredited experts following evidence-based practices. It's still listening, but it's listening by people that we know are good at listening to poor quality forensic audio, and we can follow it as a process with a beginning, a middle, and an end that we can develop on evidence-based principles. So this is a pretty big challenge. It needs a very good understanding of human speech perception, what factors affect it, under what conditions are listeners likely to be right or wrong, and especially how can we ensure that they are usually right. Or at least that they can tell you whether they're likely to be right or likely to be wrong, or evaluate their likelihood. And we do have plenty of theoretical knowledge to draw on. So as well as acoustic phonetics, which gives us a lot of great information, perceptual phonetics and so on. We also have psycholinguistics and related branches of various language sciences, and psychology would be one of them. We have a lot of different models that start from the observations about the nature of speech that I've just been showing you. So it's well known, as I said before, it's extremely well established and well accepted in the academy, if not in the law or outside the academy, that speech is not a nice sequence of phonemes that you just match, as I discussed before. But we have different types, there's many different types of models, but they generally follow some sort of computation whereby we extract bottom-up information, acoustic information, not as phonemes, but as acoustic cues, usually in some sort of non-linear formation. And then we add top-down information that comes from the listener's experience, language background, and so on, as well as their contextual information, both the internal context, what sort of sentences it is, and what other things they know about the situation. And we know that that top-down information is mostly useful, but sometimes can be biasing or distorting to perception. And the point is that the mental processes of speech perception combine those different sources of information to create words or word-like forms. I say tons of research on all of this. Some of you probably know quite a lot about that sort of area. Words or word-like forms that enable us to access the meaning of what was said. So these are useful models, and they give many insights, and they certainly make it very easy to explain why these current legal procedures that I've been describing are so problematic. But like all models, they do have some limitations, which is well acknowledged. So what are some of the limitations? Well, they're shown especially by limitations in their implementation in automatic speech recognition and automatic transcription. So back in the 1980s, I actually used to work in that field. I started off doing my PhD on automatic speech recognition, and my task was to try and figure out how can we detect word boundaries. As I showed you before, words are all joined up together. So how can we detect word boundaries? And other people were talking about how can we encapsulate all the top-down knowledge that we need in some sort of knowledge base that can be applied. And these models did have some success, but within certain quite limited constraints. You know, they were quite good for booking airline tickets and things like that. But they'd never enabled general speech recognition. And the reason is that bootstrapping problem that I showed you earlier on. You actually can't determine which cues are needed until you know which words. So it's all sort of circular. Of course, recently we've had huge developments with AI, and the AI transcription is incredibly successful through a very different approach with the large language models. And I won't try and tell you anything about that. I'm sure you all know more about that sort of thing than I do. But the point of them is that they enable the system to bypass that kind of explicit information. They don't need us as humans to tell the system all the knowledge that it needs. They start with a big database of speech, each bit of speech associated with a transcript, and then it can find statistical relations between the speech and the transcript and create a language, what's called a language model. It's not a model in the way that humans use models, but it's some sort of statistical relationship that can then be used to create transcripts of audio where there is no existing transcript. So they are fantastic. I use them. They're marvelous with clear speech. They're actually hopeless with poor quality speech. Certainly no better than humans. But they can't really explain human speech perception. I know this is a very controversial kind of thing, but I like to just cut to the chase and say, in that little explanation that I gave, even though it was only 20 seconds long, perhaps you notice that everybody says, oh, these large language models, they analyze huge corpora of speech. But that's not quite true. They analyze huge corpora of speech with associated transcripts. Where do those transcripts come from? Well, of course, they're made by humans, and they can only be made by humans. I can't even imagine what it would be to have an AI that you just give them the speech and it comes out with transcripts. Who knows the future? Maybe in 3 months we'll have that, but certainly we don't have anything remotely like that now. So it's not really like human speech perception, in my opinion. You might argue that would be fine. But the most important point of all is that people who are experts in these kinds of models, whether the old-fashioned ones or the new-fashioned ones or any other ones, AI, whether it's computer speech recognition or models of human speech perception, being an expert in all of that stuff, acoustic analysis, speech perception, psycholinguistics, etc., actually doesn't enable you to do good transcription. It enables you to explain why others make errors, but it doesn't prevent you from making errors yourself. Interestingly enough, experts in modeling speech perception are not expert in doing transcription or in speech perception itself. And we've actually shown this in our hub through some, we've been doing, I'll tell you a bit more about it. We've been doing a lot of experiments on how well people can understand forensic-like audio. And what we find is in general, people are unsurprisingly not very good at it. Typically scores, if you have a very strict, it must be exactly like the reference transcript. They typically, the maximum scores are under 50%. If you're a little less strict and say, well, if you're nearly right, you're getting some scores over 60%. This is without context. So this is nowhere near good enough. And the confidence does not correlate with accuracy very well. So it's nowhere near good enough to just use like that. So that's why we need the evidence-based process as well. But the point is, when we ask them about their language their scholarly language background, linguistics background, if you look there, we've got now, what do we, on the left, it's not never done any linguistics. And then it's applied linguistics, and then it's linguistics, and then it's phonetics, and then it's forensic speech science. And what you might notice is the range of abilities within each group is roughly similar. So within each group, the highest scores are approximately 60, and it goes down much lower. No, admittedly, some of them are not as low as some others, but we're not seeing anything that's suggesting that studying forensic speech science makes you really good at forensic transcription. And in fact, they don't claim that, but a lot of people expect that. And some of them were disappointed. They thought that they would be better than that. And I had to say, it's not about you personally, it's about, in general, what are the capabilities of people with this kind of background, so that we can be more realistic in our expectations and in the advice and recommendations that we make for the courts. So these kinds of models are very good for their purposes, but they're not suited for our purposes of doing forensic transcription. For this, we need, I think, a different understanding of human speech perception. And in particular, we need a new view of the human listener. So it's been sort of taken for granted for many, many decades now that human cognition of all kinds is computational. But there's always been a sort of sideline of people that think, well, maybe human brains or human cognition isn't like computation. And I guess I'm in that field. It's useful to think of it that way from time to time, or use models. I use those models. That's all great. But I think when push comes to shove, we can't explain our own perception as computation. So human listeners use meaning, context, tacit or implicit knowledge, informal reasoning, practical wisdom, all of these types of things. And I think we need a framework for understanding speech perception that is much more able to take those things into account than computational models. And I like to see this as similar from the change that's taken place in recent decades in economics, when we've moved from this economic rationalism where people are considered to be homo economicus, where everybody's making rational decisions about how they'll spend their money and how much they need to earn to do this and that. To now, I think in economics, we have behavioral economics, we have all kinds of things that involve observing how people really behave and talking to them about how they really make decisions and what things really matter to them. And of course, the famous ones there are Banerjee and Duflo, who won the Nobel, was it the Nobel Prize for Economics? Or I can't remember which, well, one of the Nobel Prizes a couple of years ago. So hopefully if we take this approach, we're in line for a Nobel Prize in speech perception as well, in our dreams. So the way I like to look at this is that we can see a transcript as being a representation of speech in very much the same way as a map is a representation of the terrain. So of course, a precursor to representation, before you can represent something with something else, we have to conceptualize it. So speech is a continuous reality, as I've tried to demonstrate, and a terrain is a continuous reality. And in order to represent a terrain with a map, you have to conceptualize it as a pattern or an array of discrete entities, roads and cars and trees and houses, or trees and rivers and mountains, whatever it might be, for your purpose. And we sort of can draw maps by computation, but I think we always have to give the computer a lot of knowledge that's been derived by humans doing it from scratch first. And the point here is that in order to make a map, the person making the map has to have purposeful, you have to know what the map is going to be used for. Sometimes you just want a little mud map with a couple of lines for the road and a big square saying pub to show them where they should go to meet you on Friday night. And sometimes you want an incredibly detailed thing with all the ordnance survey lines and things like that. It has to be context aware and has to use understanding and judgment in light of that context and that purpose. So I would not call that subjective in the sense, that derogatory sense of that subjective, oh, it's just whatever you feel like, anything goes. You know, I like pink, you like blue. It's just a matter of personal preference. But it is subjective in the sense that it involves some human subject making these kinds of decisions. And it's certainly not objective in the other sense where it's just a mechanical transduction where you just take the physical features and sort of blindly represent them in some sort of form. So I think these terms are just now really old-fashioned, subjective, objective. Okay, there's ends of a continuum, but there's a lot of stuff in the middle which I think has this purposeful context-aware understanding and judgment. We have a lot of relevant knowledge, both from science and from experience of human speech perception. The common knowledge, I'm emphasizing, about speech perception is deeply flawed, but we have an incredible amount of experience that we can draw on as perceivers of speech, as well as all the scientific discoveries of the last nearly a century that we can draw on. So we have a lot of useful, relevant knowledge, but we need to refine it and extend it for the purposes of this forensic question that I've defined. And the good thing is that I think doing so will have a lot of relevance beyond forensics itself to other fields. So I'll just conclude with a couple of observations about what a framework like this might do or might look like. First of all, priming comes first. So in the usual computational models, we almost always start with the acoustic cues being extracted from the speech wave in whatever form the model requires. And then the top-down knowledge is applied or added or brought in whatever way the model uses. And that's fair enough for those models. But when we're talking about understanding speech with unknown content in potentially misleading contexts, priming really creates a sort of loose expectation or hypothesis that drives an active search for the acoustic cues. We're not just picking up the cues and then dealing with them. That's sometimes called filtering, that you pick up a lot of cues and then the top-down knowledge filters out the ones that aren't relevant. I like to think of it more as being, you're looking for something with a torch. Your torch is shining where you think the most relevant cues will be. You're actively seeking those acoustic cues, and there's quite a lot of other people that would agree with that kind of view. But just finding the relevant cues isn't the end of the story. Once you've got the relevant cues, you haven't just automatically got the words. perception is a multi-stage process. We start with that expectation or hypothesis. We search for the cues. We use the cues to generate a percept, what words we think it might be, but then we evaluate that percept. And we have this wonderful thing called echoic memory. Are you familiar with that? Hopefully this will make you pay more attention to it. It's a marvelous thing that we have. Whenever you're listening to something for a certain number of seconds or minutes afterwards, you can kind of replay it like a little echo in your ear of what you just heard. So I'll give you some examples of how this can work. So these are just from my own personal experience. And I hope after this, you'll go away and you'll pay attention and you'll send me some emails with your personal experience of this type of thing. So here's an example of customer. That's me in a cafe. Oh, those look nice. What are they? Curry brownies. Curry brownies, that sounds horrible. Hang on. Could she really have said that? Then playing the assistant's words over in my echoic memory. Oh, no, it was currant brownies, not curry brownies. Okay, great, I'll have two. Okay, have you ever had an experience like that? If you say no, I don't believe you, you just haven't paid attention. Here's me listening to a radio broadcast. There's a host and an interviewee. Thanks for coming. Thanks for the beer. What? They give interviewees beer. Hang on, that can't be right. And then playing it again in my echoic memory. Oh, I see. He didn't say thanks for the beer. He said, thanks, good to be here. Ever had that experience? One more in conversation. I love these. This is my problem in life. I love these far too much. Most people get bored very quickly, but I just never get sick of them. He went with his granddaughter, Rose. That's funny. I didn't know he had a granddaughter. Hang on, maybe that's not what he said. Replaying in echoic memory. Ah, he said, he went with his friend, Walter Rhodes. This is bizarre, right? But these things happen all the time. And we can learn a lot about speech perception. If you don't know, you might be amazed to discover there's half a shelf in the library of books all analyzing these kind of errors and finding out all the irregularities in them. So what can we say? This is Bayes in action, right? I'm sure some of you know about Bayesian theories. We start with a prior expectation, and then we get some evidence, and then we revise our expectation, and then we've got a posterior what am I trying to say? Priors and posteriors, posterior interpretation, and then we can start again and keep on going and going and going. Of course, we need to operationalize this. It's all very well to say, oh, this happens, but it's very fluid. But I think forensic transcription provides a very usefully constrained context to enable us to develop a more rigorous theory based on a framework like that. And that's where I thought it might be interesting to find out more about what you guys do, because I know you have a lot of expertise in understanding and measuring complex data. And trust me, data does not come much more complex than human speech perception. So the listening-based approach that we're currently evaluating, first of all, we test listeners working with the Language Testing Research Center, and that's where we find these different levels of aptitude that people have. Obviously, we want to work with the ones that have good aptitude. We don't waste our time training people who are hopeless and are never going to get better. But just aptitude is not enough. We need to also have the evidence-based method. This is where MDAP have been very helpful. They've developed or still developing a platform called SoundScribe for us that we can use to collect transcripts from multiple listeners and evaluate and compare them and all that sort of thing. So our intention so far is to start with 2 expert listeners, the ones that pass the test very well, with no contextual information. So this is always going to be limited, but doing it that way, we find out how much information we can get from the acoustic information itself. Then we add relevant and reliable contextual information via a managed process. I don't know if you're familiar with linear sequential unmasking. That's been developed by ETL Drawer and others who are psychologists. We need to adapt it quite a bit for speech. A lot of psychologists think you can just apply other things to speech. Speech has definitely has special characteristics, but it's a useful reference for that type of thing. And the intention is to get one of two things at the end, either a demonstrably reliable transcript that can be used in court from the start without needing opinions about police transcripts, or a statement that this audio is not capable of reliable transcript, so they can't just go shopping around for another witness that will give them a transcript that they like better. Okay, so that's about it, but I would just like to end with my favorite video that I usually end my talks on. So I'll play this and you'll see it and you'll get a really important point from it. And that is a very important point, but I then want to draw your attention to another really important point that follows from it. It's pretty short. Okay, you ready? The caption, it's Peter Kay, an English comedian who does that, inducing misperceptions like that. Do you know, did you all hear your burgers are the best and the hot dogs must go on? Do you know what it should be? Your burdens I will bear, and the heart does go on. So what the obvious thing we learn is how easy it is for our ears to be misled by an inaccurate transcript, even when we know it's inaccurate. So compare that to the pact example that I started with at the beginning. It's basically exactly the same, right? I started playing you some speech, and then I induced you to mishear it. But nobody was laughing or nobody was saying that's outrageous or anything. Everybody just sucks it up. But here we know for sure that this is wrong. And nevertheless, we still hear those words. That shows the power of this kind of priming. It's not something that you have conscious control over. It's going to happen to you. You have to protect yourself from misleading transcripts. Otherwise, this will happen. And it's once it's happened, you can take various kinds of steps if you know what you're doing, but it's better to avoid it happening in the first place. So we have to have a clean process for forensic transcription. But the other important thing is, he sort of tricks us, but he sort of doesn't trick us. What makes it funny is we know it's not real. We're hearing something that we know isn't real, but our ears are telling us it's there, but we know it's not real, and that's what makes it funny. So this is like another level of priming, where it's the level that says, oh, I know I've bought some tickets and gone to a performance where I know somebody's going to make me laugh, or I'm sitting in a seminar with somebody who is going to teach me to doubt my own perception and realize that we shouldn't use police transcripts and stuff like that. This is another level of context. And that's what I mean by all these levels of implicit awareness. You can't always make it explicit. Once you make it explicit, then you still need some more implicit contextual knowledge in order to interpret that explicit contextual knowledge. So that's where I'll leave it. Thank you very much. If you'd like any more, there's some websites and things there. I'm very open to emails, and my email address is there.